Alright, so this is going to be a demo of hypothesis testing for correlational design. So this is just an abbreviated version of what we saw in the previous correlation video. What we're going to look at here is how to perform a hypothesis test to get a p-value in SPS or in Excel with correlation, which is best done under regression. So we'll go through these steps real fast to get descriptive statistics. Here we have two variables, stress and symptoms, for a total of 20 people. And what we're wanting to see is whether or not there is a relationship between the amount of stress report and the number of physical symptoms they report. So the first thing we want to do is identify the alternate hypothesis. The alternate hypothesis is basically what the researcher expects. So we would say the hypothesis is that there is a significant relationship between stress and physical symptoms. Now, of course, we probably have a directional hypothesis here. That is, that as stress increases, symptoms increase. But we're just going to look for a relationship. And so we're going to worry about this not as a one-tailed test, but as a two-tailed test. That is a non-directional hypothesis, about there being a relationship in general, not about there being a positive relationship or a negative relationship. In statistics, we often do non-directional tests because they're more conservative. They demand a little more evidence, if you will, to reject the null hypothesis. And so you really have to justify using a one-tailed test for the most part in statistics. The expectation, unless someone says otherwise, is to do a two-tailed test. So the null hypothesis would be the statement of equality. And so in this case, we would say there is no relationship between stress and physical symptoms. So the null hypothesis basically says whatever you think is incorrect. So if we were going to try to do these in symbols, we'd be talking about the alternate hypothesis being that the correlation, represented by R, Pearson's R, does not equal 0. And what this means is that there is a relationship. The correlation is statistically different from 0, and a 0 correlation means no relationship. Now, as you learned in your video, the null hypothesis often contains the statement of equality, and in this case, we would say the null is that R is 0, that is no relationship. So this is what we'd be testing, is this correlation relationship with the alternate null hypothesis specified. So we could get some descriptive statistics for these values. If you remember how to do that, we go to data analysis. Under descriptive statistics, we can put in our data. And here we get the statistics to summarize our two variables. So we have stress and symptoms. We have the means, the standard deviations, all of these different things to summarize them quickly. And now what we want to do is perform a test to see whether or not they're related. So the easiest way to do this would be to use the regression function. So there is a correlation option that we can perform here. We'll look at both. Under correlation, we would grab our data that we're going to input, and it's grouped by columns, and we're going to put our output right next to our descriptives and hit OK. So you see here when we just do a correlation, column 1 would be stress and column 2 would be symptoms. We get a correlation value right here. This is the relationship between stress and symptoms, and so this is Pearson's value. Now, looking at this, it's not 0, but that's what we call a descriptive difference. The real question is this difference statistically different from 0, not descriptively? You could have numbers that aren't 0 that statistically speaking are not significantly different from 0. And there's all kinds of criteria that go into determining that. So we really want to get what we call a p-value to measure this relationship. Now, if you notice that the simple correlation option here didn't do that for us. So what happens if we go to regression? If we go to the regression option, we select regression, and we're going to put in our variables. So my y variable I'm trying to predict symptoms, and I'm predicting that from stress. So I selected symptoms and stress here. I'm going to put my output over this correlation stuff, and we're going to go ahead and run our analysis. We're going to overwrite that existing data. Now, notice, I still get my correlation value. You can see it right here. But I also get a test of significance for the relationship here. The x variable is the slope. This is going to test the relationship. So here I have a p-value that goes with the t statistic, and these are testing to see whether or not this value is different from 0. So in case you forgot, we can see if we do the correlation function for our two arrays, that this number is the same number that we get using the regression here for multiple r. So this is why regression can get us everything we need. This would be our r value. And then down here, we have our two-tailed p-value. And so this is what we would use to determine statistical significance. And now remember, we typically use p of less than or equal to 0.05 to determine significance. This p-value is 0.019 or rounded to 0.02, which is less than 0.05. As a function, we would say that this is a statistically significant result. What that means is that statistically, this correlation is different from 0. So this would mean we would call these results statistically significant. In intro stats term, that would mean we reject the null hypothesis. And with respect to the study we conducted here, we would say there is a statistically significant relationship. R equals 0.519, P equals 0.019 between stress and physical symptoms. And so that would be the finding from the analysis that we conducted. All right, so hopefully that helps you understand a little bit of how to do the test of correlation and the hypotheses that go with it in Excel.